Hi, in this video, I want to show you how you can use Python for data analysis and visualization. I'll discuss some of the main libraries used for this purpose, along with an overview of their capabilities. We'll be covering data analysis libraries such as Numpy and Pandas, as well as data visualization libraries like Matplotlib and Seaborn. I'll then do some analysis using a real-world dataset to show you how these libraries can be utilized. Now, this video isn't an extensive tutorial. It's just a taster to show you the art of the possible, so please keep that in mind. I will provide details and additional resources should you be interested in learning more and diving deeper. Okay, so let's get started. So why should you use Python for data analysis? This is because Python is a great general purpose language, and it comes with many libraries as well as built-in tools that provide an extensive range of capabilities, not only for data analysis, but also for a wide range of things. The focus of Python is to be simple, flexible, and easy to learn, so it's great for beginners. The most common libraries for data analysis in Python are Numpy and Pandas. Numpy is useful for mathematical and scientific operations. It's used on array data structures. Array data structures are objects that contain a grid of values. You'll probably use Pandas far more often than Numpy, and that's because Pandas can be used on series and data frame objects. So if we compare series and data frames to a table that you might find in a relational database or a spreadsheet, well, a series would be like a column of that table, and a data frame would be like the table itself. So a data frame is essentially a collection of series, just like how a table is a collection of columns. Both data frames and series have indexes. This is used to identify the elements within that structure. Similar to tables, data frames also have column names. Pandas can do many things. It can read data from multiple sources, including SQL databases, Excel files, CSV files, and the list goes on. It reads data in tabular form and converts it into a data frame. You can then perform many different operations on this data frame. You can do things such as group the data frame, summarize the data frame, filter the data frame for specific records, and even join multiple data frames together. As well as Numpy and Pandas, which are great for data analysis, there are many great libraries which are perfect for data visualization. Two very common ones are Matplotlib and Seaborn. Matplotlib is one of the oldest data visualization libraries in Python, and it's considered to be low level. This is because it usually takes quite a bit of code to create certain visualizations, but you have greater control and flexibility over how the visualization looks. Seaborn is actually built on top of Matplotlib, meaning you can use Matplotlib functionality with Seaborn, but Seaborn is considered high level. It can produce great visualizations with just a few lines of code. Matplotlib and Seaborn are often used together, and you'll see this when I take you through the example exercise. In addition to these two libraries, I'll also touch on Plotly, which produces really amazing interactive charts. There are lots of other libraries in Python too. If you have a specific requirement, the chances are that you should be able to find a library to help you with that requirement. Okay, so now that we've covered all of that, let's dive into an example with a real dataset. For this example, I'm using Jupyter Notebook via the Anaconda distribution. This comes with all of the libraries I've discussed pre-installed. I've got a separate video providing installation instructions and an introduction to Anaconda, as well as how to use Jupyter Notebook, so check out that video before we continue if you'd like to code along. I'll also share a link to the notebook I'm working on, which you can download along with the dataset, which is on my GitHub. Okay, so I'm currently in a Jupyter Notebook file. The first thing you need to do is import your libraries. Let me start with a quick example showing what you can do with Numpy. So I'll import Numpy as NP. So you import Numpy as NP, and then you can reference Numpy using the alias NP, which is the standard. So let me create a list of numerical values and assign it to the variable val, V-A-L. And I'll just make it 1, 2, 3, 4, 5. So Python has a number of built-in formulas you can use. So if you wanted the sum of the numbers in this list, you can simply pass in the list inside of the parenthesis of the sum function, like so. And you get the answer, which is 15. NumPy offers additional functionality, specifically mathematical and scientific computations. So, for example, if you wanted to apply a trigonometric function, such as sine, to each element, you can do so, like this. np.sine, and then pass in val. So you access the sine function by prefixing np followed by dot. This accesses the functions and methods in the NumPy library. Each element is the result of the sign of that number. So sine of 1 is 0.8417098. NumPy works with lists, as you've just seen in this example. Lists are a standard data structure in Python. You can see that the type of the list, which I've stored in the variable val, by using the following operation: type val, and that returns list, because val is a list. NumPy can also use arrays, which are computationally much faster than lists. You can convert a list to an array like so. So I'll create a new variable called array_val, and that will take np.array, and then I will pass in val, which is my list. So this is now an array, and you can check the type, and it's a NumPy ND array. Okay, so now let's import pandas and analyze a dataset with the pandas library. As I've mentioned, pandas works with series and data frames. Data frames are similar to tables. So in the same directory as this notebook, I have one CSV file called races. So here you can see the CSV file, and this is my directory. It's currently untitled. So let me open this file. So here's what it looks like. Races contains data for all Formula 1 races that have taken place between 1950 and 2020. Let me show you how to import these tables. So let me first import pandas as PD. You can import a data frame by using the following command: pd.read_csv. And inside the parenthesis, if you press Shift and Tab, you can get additional documentation, such as the parameters that this method accepts. We only really need to provide the file path to the file in this instance. This can be the full file path or the relative file path. Since the file is saved in the same directory as this notebook, I can just pass in the file name. So inside of single quotes, I can just pass in races.csv. So now you can see a preview of the data frame. The ... in the middle is to signify that there are more records. You can assign this data frame to a variable. Let me assign it to the variable races. So let's check the type. So as you can see, the type is a data frame. You can select a single column from the data frame using square brackets, and then referencing the column name, like so. So at present, in the races data frame, we've got all of these columns. So let me just grab the race ID. So in square brackets, I'll type race ID. So let's check the type. So the type of this is now a series. And as I said, a data frame is a combination of series objects. You can also check the summary of the data stored in the data frame by using the info or describe methods, like this. So if I type races.info, open close parenthesis, you get information on the columns. So you can see how many records there are, 1079, and then how many null objects there are, and the data type. You can also type races.describe, and then you get mathematical information for each numerical column, such as the count, the standard deviation, and the quartile ranges. You can even check the data types by typing races.dtypes. So currently, the date column is an object data type. You can convert this to a date by using the pandas to_datetime function, like so. pd.to_datetime, and then you pass in the column in question, which is date. So this now returns it in date format. You can assign this to the column name using the assignment operator, and then press enter. And now when I check the data types again, you can see it's now a date time. There is so much you can do with pandas. You can summarize and group data, combine data, apply formulas, transform data. The list is endless. I'll link the official pandas documentation in the description so you can learn more. Let me do one final thing with the data frame. So first, let me just call the data frame again, which is stored in the races variable. I want to transform this data frame before I visualize it with the charting libraries. I want to group it by the specific Grand Prix, which is in the name column, and I want to count the number of occurrences of each Grand Prix. You can do that using the group by method in pandas. So I want to group by this name column, and you can do it like so. You just type races.group by. And inside of the parenthesis, if you press Shift and Tab, you can see the documentation. I need to specify which column I want to group by, and that is the name column. It should be in single quotes. So this creates an object. You need to apply an aggregation function to this object. I want the aggregation to be count, so I'll apply the count function after the dot notation. So what this does is it stores the Grand Prix name as an index. So this is no longer a column, it's an index. And for each column, it provides the count of occurrences. So this will be the count of non-null records in each column. You can actually just pick any one of these columns, and that will be a count of the occurrences of that Grand Prix. You just need to make sure that it doesn't contain any null values. So let me pick race ID. So here we go. You can then reset the index so that the name is a column by typing reset_index. And now we have a 2-column data frame with name and race ID. Let me assign this to a new variable called summary. You can even filter the data frame. Let me show you that summary contains all of this information. But first, let me change the name of this column from race ID to total, because race ID is not representative of what this column represents. This column represents a count of the occurrences of each event. So you can do that by typing summary.rename, and then we're renaming the columns, and then you pass in a dictionary, and then you say the old column name, which is race ID, to the new column name, which is total. And I'm just specifying in place equals true. And this means that the changes will be in place. So this data frame will hold all of the changes I've just mentioned. So now if I check summary again, you can see it's changed from race ID to total. So now let me filter the data frame so that only the events that have occurred over 30 times are returned. So I can do that by typing the following. In square brackets, I can write summary total greater than 30. And now only the events with over 30 occurrences are returned. So let's break this down. What's happening here is if I delete this, I've got a condition here, summary where total is greater than 30. This returns true where the condition is met. If I then apply that to the data frame again and pass it in square brackets, only the records which return true, are returned. So now I've managed to filter the data frame. We can even then sort this in descending order by using .sort values and then by total, and then specify ascending as false because we want it in descending order. And now it's sorted. So let me assign this to a variable called top GP. So as you can see, there's a lot you can do with pandas. This is just a short demonstration that's intended to show you what's possible. Check out the documentation for more information, which I'll link. I also have a course hosted on Udemy called Python for Data Analysis and Visualization. It contains over 10 hours of online video tutorials and will dive extensively into Python. It also covers the data visualization libraries I'm about to discuss. So if you want to get a proper understanding of these libraries, then please check out that course. I'll leave a link in the description. Okay, so now that we have our summarized data frame, let's plot it. So the data frame is called top_GP. And if you want to return only the first few records, you can type .head, and that will just return the first 5 records. So this is what the data frame looks like. So before we plot anything, let's import the library. I'll start by importing matplotlib.pyplot as PLT, which is the standard. Matplotlib comes with a number of charts you can choose from. I'll keep it simple and create a bar plot by typing plt.bar. If you press Shift and Tab, you can get documentation. So X will be the x-axis coordinate, height will be the height of the bars, so essentially the y-axis coordinate value, and then there are other parameters as well. For now, I'll only use the x and the height parameters. So I want the x-axis to be the name column, so I can type x equals top GP name, and then I want the height to be top_GP total. So let me press enter. So this chart is quite small, and you can't really read the labels. You can customize the size like so. So before this, I can type plt.figure, fig size, and then you can specify the size in inches. I want it 20 by 10. So now the chart itself is bigger, but you still can't see the labels. So let's change the orientation of the ticks from horizontal to vertical. So I can do that by typing plt.xticks rotation vertical. And then to remove this block, I can just type plt.show. So this will then print the image. And actually, let me just make this a bit smaller, 15 to 10. 8. Great. So now the chart is a lot more legible. So now, what if I wanted to color each bar specific to a Grand Prix? Well, I'd have to have a dictionary of colors and specify this in the color argument. So let me just zoom out. What I would have to do is have a list of colors. So for each GP, I've got a color assigned to it. And then in the bar itself, I would use another argument called color. And that would be the top_GP name, which will be mapped to this list, to this dictionary of colors. So as you can see, while we can customize the chart, it's starting to use quite a bit of code. This is where Seaborn comes in handy. Let me plot a similar chart using Seaborn. But first, I'll import the library. So import Seaborn as SNS, and that's the standard. So let me zoom in a bit again. So to create a chart using Seaborn, I can type SNS dot bar plot, and I could just pass in X as top underscore GP name, and instead of height, you can just pass in Y top underscore GP total. So as you can see, it's already a bit nicer aesthetically, and the bars each have their own unique colors. You can also change the size too. The great thing about Seaborn is it works with Matplotlib functionality. So I can even use plt.figure to change the size. So I can actually just copy this line, and it should work with Seaborn. And then I'll just type plt.show at the end, and that works fine. And similarly, you can change the ticks as well by using the same line. As you can see. So we've been able to use Seaborn to plot a similar chart with fewer lines of code. In addition to Matplotlib and Seaborn, there are many other libraries too. Some other libraries like Plotly allow you to create interactive charts. So I'll quickly create the same chart above using Plotly Express, which is another powerful library that produces interactive charts. So I'll import plotly.express as px. And then I can type px.bar, and then for the x-axis, I will have name, and then for the y-axis, I will have total. And now we have a really nice looking chart, which is interactive. So if I hover over it, you can see the values. You can even cross-select different elements of the chart, zoom in, as well as zoom out. And all it took was a single line of code with 2 parameters. Okay, great. So I hope this quick introduction gave you an idea of what you can do with Python in terms of data analysis and visualization. There are lots of possibilities and a wide range of charts you can create. If you want a more extensive and in-depth tutorial, then please do check out my course, which I'll link in the description.